Check, check. All right, I think we're going to get started. If you can find your seat, that'd be helpful. All right. And if you're a founder presenting today, if you can sit close to the front, that'd be really helpful so that we're not trying to chase you all down as we transition. Welcome, everybody. So cool to see. By the way, isn't this space really cool? Big applause to Drew and the whole On-Ramp Hub team. I'm getting WeWork flashbacks. All right. This thing is fun to play with. All right. Well, greetings, everyone, and warm welcome to Ensign's Emerge Showcase. We're absolutely thrilled to have you all here. Special shout out to our viewers tuning in via the YouTube stream, including our esteemed colleagues at DIU and Ensign, our friends at the other defense innovation on-ramp hubs around the country, and our incredible partners. My name's Josh Carter, and I'm the Emerge Program Manager. And before we delve into the exciting presentations ahead, let's take a moment to unpack what the Emerge program is all about and its overarching objective. At its essence, Emerge is dedicated to empowering teams working on innovative technologies originating from universities and equipping them with the knowledge and tools necessary to bring their creations to market and navigate the intricacies of engagement with the Department of Defense. Throughout the program, participants have had the privilege of learning from experts across various domains, including non-dilutive funding, financial model, sales strategies, hiring a team at scale, and more. Moreover, they've had invaluable opportunities to forge connections with one another, embark on the entrepreneurial journey, and gain insights into the DoD ecosystem. A pivotal aspect of the program has been its emphasis on storytelling. Effective storytelling not only enhances the founders' ability to communicate their vision, but also resonates across platforms from their websites to pitches, ensuring clarity and impact. Today, we're privileged to witness 13 remarkable stories, each reflective of dedication, ingenuity, and passion. Before we get too deep into today's event, I want to extend my sincere gratitude to the individuals whose unwavering support and dedication have been instrumental in bringing the Emerge program to fruition. This marks a significant milestone for Ensign, as this is the first time we've executed a program in-house. And it wouldn't have been possible without the collective efforts of our outstanding team at Ensign, DIU, as well as our incredible speakers. So I especially want to thank folks like Javier Gomez, who without his help, the program would have been in real trouble. Brady Ryan, Mike Dingman, Mary Kate Bell, John Hrivnak, Courtney Foley, Francisco Molinero, Patience Lowry, John Griffin, Drew Trojanowski, and the entire on-ramp team here in Phoenix, and my esteemed colleagues who help run the programs on the venture portfolio team at Ensign. It takes a team effort to put something like this together, and I'm honored to work with these people. If I missed anyone, I apologize, but know that I appreciate your help. So as I wrap up, I'd like to talk a little bit more about what you're going to see. 13 teams are about to present their technology, and it's not a stretch to say you're going to watch teams that are changing the world. Now, I know you've heard that kind of rhetoric at other programs, and I agree. However, I have never seen these kinds of solutions during my time running WeWork Labs, or when I was the CEO at Patriot Boot Camp, or even running international program and accelerators for cluster organizations out of Washington State. Now, what you're going to hear from these founders will really change the world. And as a former founder, I can tell you what they're doing is really difficult. But it's made even more difficult when they have to do it alone. So I have an ask. Help one team, just one team, make your network their network. If each one of you here and on the stream can help just make one connection, give them feedback, or simply be an empathetic ear, these teams won't have to walk through so much glass to grow the maturity of their company. So thank you for being here. I really appreciate it. And I'm going to turn it over to Drew, who's going to talk about the mission of the on-ramp hubs and talk a little bit more about what they do here in Phoenix. So Drew, without further ado.
Thank you. I appreciate it. I apologize too. I'm a little under the weather, so if my voice cracks or I just start wildly coughing, I apologize on the front end of that. Thank you. Thank you, Josh. Thank you, DIU. Thank you, Ensign. Thank you to everybody. This is a long time in the making. Ensign's been running an iteration of this program for the last, I don't know, 3 years, and it's been instrumental in helping the ecosystem, working within academia to help teams that have promising dual-use technologies to figure out, how do we take something out of an academic institution and start to mature that into a full-fledged company and get that thing across the goal line so that it can have an application for DoD. And so you guys are standing, at the precipice of something great, and this is just a very unique time for DoD. This decade is shaping up to be one of the most consequential of all of our lifetimes. You may or may not realize or know that, but this type of activity is only going to accelerate, where you have things that are very successful in the commercial marketplace that the Defense Department is trying to adopt. And so programs like Ensign and programs like ours with the On-Ramp Hub are here in the ecosystem to help support you guys figure out how to get to DoD. And so very specifically about the hubs, so as you can see, it's a physical co-location space, right? But we are an industry counterpart to the DoD innovation offices. So while they're very good on the DoD side of the fence, you have an amalgamation of a lot of different folks, not just here in Phoenix, but across the country, who have very specific expertise and provide transition as a service in a lot of ways, working directly with the government counterparts. But what are the additional services you'll need? Because your time, your journey is not going to end right now with this program, right? So there's going to be additional needs, and it's going to be a spectrum of needs. So what are those that we can provide? Is it going to be compliance issues? Are you going to need help with proposal management? Are you going to need project management? Are you going to need engineering as a service? Are you going to, what are those things going to be? Are you going to need to figure out how to get to experimentation? Are you going to need to figure out, so that's where we're here to be supportive of you guys. Once the program ends, we can figure out how to help you navigate, so you can actually transition those things to the government program offices. Also, I want to shout out a handful of people. I haven't thrown their hands up, but we have some observers here because I want to make sure that you guys have the opportunity when you guys get done. All these presentations will happen, but you're going to have some DoD folks in the room that I want you to be able to talk to just to make sure that there is, what is the real world application for this, or where do we go after this, or what are some of those pieces, right? So if I could have, just because I see you first, Kyle Olson. So Marine Innovation Unit, or do you want to say something real quick? No. Okay, so Marine Innovation Unit is a local VC here as well. Taj Holmes is not here. He'll be here shortly. He called me right before he got here. He had a flat tire, but he's with USURPAC Concepts. So they are on the vanguard of trying to find new capabilities. So I've told them about all the teams that are here. They were very keen on figuring out, hearing, and then figuring out how to integrate those into future experimentation and scenarios that they've been developing. Dakota. So Dakota's with AFWorks. And then Jim in the back. Would you raise your hand? So Monsoon VC, based out of both here and Salt Lake City. So you just have folks here that are going to be listening to use cases and figuring out how to help support after the fact. And then again, for us, we're here to be supportive as you can, right? So we'll figure out, what follow-on steps come after that. And then lastly, to the point that was made earlier, if you can help just one person, a lot of you may or may not know the people in the room. So the people who are here that are local, find a team, have a conversation, make friends, and kind of begin that process of how to be supportive. And so with that, I'll stop and I'll turn it over to Ensign. I believe you're coming up next, Alyssa. Okay. Thank you all.
Okay, good morning. Thank you. First of all, I just want to thank the On-Ramp Hub team for hosting this. This is really a very critical part of the execution of the mission of Ensign. And so the space that you're in, we hope to be utilizing it a lot more going forward. But I also want to not only thank them, but to thank the participants, because you are the reason why Ensign exists. We put these programs together to bring these non-traditional solution providers into the DoD. And so thank you so much for those of you who traveled to be here. It means a lot and really shows your dedication to the program, and I'm sure Josh really appreciates that. Quickly, just to introduce myself, I am Alyssa Robertson. I actually have a lot of DoD experience, as my physical location is at Naval Surface Warfare Center in Crane, Indiana. But I am our command's liaison to Ensign and DIU, but I've also been acting as the Midwest regional director for Ensign for the last several months. And I hope that, after seeing all these presentations, if I have a DoD part that I can give you some advice on, I will definitely take that stance, but I also want you to know that you can come to me about anything Ensign related. So Abby Desjardins is our venture portfolio director, and she was planning to be here, but ended up being unable to make it, so I will try to represent her as good as possible. But really, for my few minutes of time that I have to speak with you, I just want to go over Ensign for those of you who may be mission partners and you're not overly familiar, if you're VC, and also for the participants of Emerge, so that you kind of know what other opportunities might be available to you. So first of all, I'm just going to go through the 5 W's, so the who, what, when, where, and why. So who is Ensign? National Security Innovation Network. We are aligned under Defense Innovation Unit, and we now report directly to Secretary of Defense. So we are not embedded within any one service. We service all of you. The what of Ensign, so essentially we have programs, and we have them mostly aligned to 2 different portfolios. So half of them are in talent, that is mostly focused on workforce development, connecting with academia, and some prototyping as well. And so there are several programs listed on the ensign.mil website under the talent portfolio that you can look into. And then the other half is venture, which Emerge comes out of. And so venture is mostly focused on entrepreneurs, licensing IP out of the DoD or academia. It also looks at early stage ventures and startups. And then we also have what we call a transition cell. And the transition cell is comprised of a bunch of subject matter experts in a variety of topics that really are resources to all of you and to other companies. So whether you have questions about CIBR and CITR or OTAs or contracting vehicles, we have someone that can kind of guide you through those processes and answer any questions you might have. The when, so most of these programs are aligned for talent specifically to the academic semesters and the academic calendar year. And then the venture ones, we usually run X number of iterations for every program every fiscal year. So you can get online and connect with the program managers. They're all listed on the website under our team section. You can connect with the program managers, find them on LinkedIn, reach out, and you can get more information about their program specifically and how they might be able to connect you to a mission partner with a specific gap that you may be able to provide a solution for. So where is Ensign and DIU located? So we have the 5 on-ramp hubs, this one being the one that we're here today. We also have Hawaii, Seattle, and Dayton, Ohio, and in Kansas City. Those are the other 4. So we have those as a part of Ensign that we've just recently launched. And you do not have to be physically located in the region of those, but you can reach out to them because they all have different networks. Then we have a Joint Innovation Lab, which is a co-working space in DC, as well as the DIU office in Mountain View, California. So just kind of thinking where you're located and what may be a good resource to you. And then we have some new co-working spaces that have just been opened in Austin, and we also have a presence in Boston. So if you're near one of those, you can seek those out. But the beauty of Ensign is that we don't only have physical locations, we are a network of people, and we are spread all across the country. So I wanted to, obviously, you know Josh, if you've been participating in Emerge, and I'm mostly in the Midwest, but Sammy is in the back of the room, and she is your rep here in, Drew gives her a nice cheer. So she is the rep here in Arizona, and she can help connect you with academia and other mission partners as well, and get resources to you for a variety of your needs. And then the why. DIU has really been tasked with rapidly scaling solutions to meet the mission so that our warfighters, if forced to fight, can win. And not only that, to have an undeniable advantage. So we are looking for non-traditionals with innovative solutions, and we see you as a critical part to that. So we hope that not only can you be successful as a part of Emerge, but that you can potentially participate in other programs, and we can get you connected with the right mission partner that will allow you to take your solution and get it fielded or get a contract or get you connected to the right people that help you develop it further. So if you have any questions, like I said, Josh, myself, Sammy, you can reach out to us. We're happy to answer questions and connect you to other folks within Ensign and DIU that could be a service to you. Thank you.
Thank you, Alyssa. All right, you guys ready to see the pitches? So not awake, that's okay. All right, we will start with Jeff and Armada.
Thanks, Josh. Before we start, since I was told we don't have to stick to 5 minutes, I'm going to go ahead and say thank you, Josh, thank you, Drew, on behalf of everyone here for leading this accelerator. It's been a really great experience, so thank you. So, hi, I'm Jeff Cayley. I'm lead scientist of Armada Marine Robotics. We're a blue tech startup out of the Woods Hole Oceanographic Institution on Cape Cod in Massachusetts. We're combining our portfolio of innovative SBR-funded technologies to build the SpaceX of the sea, which is a mobile constellation of underwater data collection nodes that will revolutionize how we can predict the future. So the problem is urgent. Earth's climate is warming. Last month was the 10th straight hottest month on record. Where is all this energy going? The oceans. The oceans have absorbed 90% of the heat generated by human activities. And heat is hurricane fuel. Already, this 2024 hurricane season, meteorologists are forecasting 23 named storms and 5 major hurricanes because of elevated temperatures in the North Atlantic. Storms aren't just getting stronger, they're also getting less predictable. This uncertainty impacts multiple billion-dollar markets from housing and insurance to agriculture and aquaculture that rely on accurate risk models and have direct impacts on regional security, regional stability, and national security. We can't understand what we can't measure, but the oceans are opaque. Something needs to physically be there to make a measurement of temperature, salinity, chemistry, or currents below the ocean surface. This is hard, so our oceans end up being undersampled. Why does this matter? Because data is AI fuel. From healthcare to finance, agriculture to cybersecurity, AI is revolutionizing industries wherever data is available. But ocean-related AI applications are significantly lagging behind land and air-based AI applications because of this data gap. This, despite projections that the blue economy is expected to grow at twice the global GDP and reach $3 trillion by the end of the decade. So where does global interior ocean data come from today? It comes from thousands of profiling floats that we manually toss off of ships and hope they drift somewhere useful before the batteries die. It comes from hundreds of sensors we tie to anchors and leave for years, hoping they're in just the right location to measure the phenomenon we're trying to understand. Yes, autonomous underwater vehicles, or AUVs, have revolutionized ocean data collection, but they're million-dollar microscopes when we need a panoramic view composed of inexpensive pixels. We need simple platforms that are mobile enough to make measurements when and where data is needed to improve AI predictions. We need scalable operational models that don't rely on crewed ships because our pace of national threat outbuilds us 200 to 1. So how do we get there? For starters, when I look at a map of the ocean, I don't see ocean currents. I see satellite orbits of an underwater constellation. Over the past few years, Armada has been laying the foundation for a full-stack solution to scalable ocean monitoring. Our asymmetric propulsion epitomizes simplicity by providing both thrust and steering using only a single motor. We've won an NSF STTR, 2 patents, an exclusive license from Woods Hole, and just last week were awarded or selected for an OSD SBIR. Our external payload delivery system on the lower left allows AUVs to deploy sensor nodes through a clever ballast change technique. We're currently executing a Navy Phase 2 SBIR and will be conducting in-water testing with that technology this summer. Each of these innovative technologies independently has DoD applications. However, non-DoD customers are less likely to own their own AUVs. We see an opportunity to combine our portfolio of innovative technologies to create a dual-use platform that fills a gap between AUVs, floats, and moorings. Manufactured, launched, and recovered from co-located shore facilities in strategic locations, Armada's platforms will adaptively ride ocean currents to achieve dynamic persistence in ocean monitoring. Our model is massively scalable, allowing us to rapidly focus on delivering high-quality data to our customers and early value to our shareholders. The Armada team brings together engineering expertise and business acumen through a shared passion for technology innovation and sustainable ocean solutions. I'll close with 3 asks. First, if our technologies can address a pain in your market, we'd love to hear more about your needs. Second, we're looking for phase 2 option and phase 3 SBIR transition partners for our external payload delivery system. If you don't connect today, Armada has a sidebar on Wednesday afternoon at the upcoming UMST review in Panama City. Finally, we feel that the next 6 months is the right timing to start building out our stack. We need to round out our team in areas of manufacturing, ocean and climate modeling, AI and cloud architectures, and risk modeling. If you or your firm has an upcoming seed round and wants to take a bite out of a large, growing, and impactful market sector, we'd love to chat. Thanks so much for your time.
All right.
Covert defenses.
Thank you very much. Thanks. Hey guys, good morning. Hopefully the coffee is starting to kick in. Today I'm going to talk about this tiny company out in the Midwest with really big dreams called Covert Defenses. I'm Arvind Sundaram, co-founder and senior data scientist, and I'm here to take you all on a little journey about how you can do really cool things if you're nice to your grad students. So Haney and I founded Covert Defenses back in 2018 when addressing the problems of finding anomalies in nuclear reactor data. But we're overthinkers, so we started wondering, what if the data was just false data given by a bad guy? What if the bad guy is a certain country who's already in our systems and knows the ins and outs of it? What if I, the designer of the algorithm, become the bad guy? Now I know that sounds like a villain arc in the making, but we decided to use that for good instead. So enter Covert Cognizance, our flagship technology that can tell you if your data is real or fake. Over my PhD, we've also added additional functionality, such as the ability to recover the real data in real time and even go on the offense, which is what put us in business. Why? Because ransomware attacks. A report by Thycotic says that over 83% of victims end up paying the ransom. Why is that? That's because it costs far more to take your systems offline or risk losing them to physical damage than to just pay the ransom. These systems are built with legacy equipment, decades old, that was not designed with cybersecurity in mind. The need of the hour is to ensure that these systems are not taken offline when a cyber attack hits them. But existing solutions cover them in layers and layers of network and communication protocols. The caveat here is that if these defenses are penetrated, your system and your data is left at the mercy of your adversaries. We wanted to change that. With Covert Cognizance, we found that the data that goes through these systems, temperature, pressure, pH levels, these data, they're not inherently defenseless. They're actually quite smart and have a lot of empty space in them, a built-in backup of sorts that's just ignored and unused by most data processing algorithms. We call these blind spots, and what our technology does is it turns these blind spots into repositories that can take information from one or more data streams and hide it in another without the use of any additional variables or modifying any metadata. What we can do is we can get a swarm-like intelligence when these data streams are aware of each other. My co-founder calls it the Borg Collective from Star Trek. But jokes aside, it is this swarm-like intelligence that gives us the million-dollar edge. With our technology, we can ensure that you can detect fake data without any false positives, and you can recover the data to continue zero downtime operation without needing any external backups, any additional surveillance, or even the need to outsource your data to a third party or an external agency. Everything is on-prem. And this idea then started to gain traction. With help from the DHS and the DOE, we have SBIR grants to help commercialize the software with feedback from Siemens and a hardware with GTI Energy, a collaborative with over 500 commercialized products in the oil and gas sector. We also have several spin-off technologies, and I can demo 2 of them after the pitch over there. So what does the future look like? We would like to develop a product suite that can be integrated into any data processing system. And what it can do is it can authenticate the data, heal the data if there's been a compromise. It can mask the data to prevent reverse engineering and ensure that any AI algorithm only sees what it really needs to see. There are many sectors out there. We talked to over 400 customers, and we found that we have a market that's way beyond just the $1 million idea that we envisioned. Manufacturing, reactors, oil and gas, drones, you name it, they've all been victims of ransomware attacks or spoofing attacks that either corrupts the data or denies access to it. With our technology, you can recover and operate these in real time. So cliches aside, we thought, why not literally take this idea to the skies with a use case for DoD that actually brings Star Trek to reality. We are doing some technical feasibility studies on drones right now to achieve this swarm-like intelligence, which fits in really neatly with the Replicator initiative that relies on fielding hundreds, if not thousands, of such drones. With our technology, they can operate in real time in both contested and denied environments. So why am I here today? With a little bit of that magic green stuff, we can actually deliver a prototype to your hands in the next couple years. But why I'm really here today is also to do some customer discovery and brainstorm use cases with both end users and program managers within the DoD and leverage our right to sole source contracts based on our SBIR work. So if you're intrigued and you want to catch a piece of covert cognizance, all you need to do is come find me with my demo. Thank you.
Appreciate you. That was great.
Thank you.
All right, next one. EMP, Rodolfo. All right. You guys still awake? Everybody's good? All right. All right, floor is yours.
Hello, everybody. My name is Rodolfo Rodriguez, and I am a staff scientist at EMP Technology Solutions, and I'm going to talk about our solution for radiation detection. At EMP Solutions, we have found three main issues with radiation detectors. The first one, they are not portable. We need portable radiation detectors. Current radiation detectors, as you can see in the pictures, are bulky, are heavy, and they are not compatible with current technology needs. Second, there is a need for efficient radiation detectors. What it means, that current radiation detectors have a dependence with the size. The bigger they are, the more efficient they are. And then also, they can detect only one radiation line. So if you need to detect neutrons, you are going to get a neutron detector. If you want to get a gamma detector, you are going to get a gamma. So only the line that you are looking for. So this is very inefficient in terms of applications. And there is a need for cheaper or inexpensive radiation detectors. What it means is that, for instance, the current competitor worldwide that we have, it sells its units at 7,000 units each, plus a subscription fee. So, and this is the one that is comparable to our solution. So our solution is we have a portable, efficient, and inexpensive radiation detector. So we reimagine the core of the detector to make it compatible with current technology needs. And also, we make it modular, which means that depending on the customer needs, we can place X-ray detectors, neutron detectors, gamma detectors. In this unit, we are currently able to detect neutrons and gamma detectors, and gamma rays. So we also have Bluetooth communication, we have Wi-Fi communication, we have long battery life, we have USB communication. We also develop the software. We develop a multi-OS interface software. We have it for iPhone devices, for Windows applications, depending on the needs. It's the software that we can propose. We have multiple notifications, but the main thing is we have machine learning algorithms that allow us to do isotope identification and anomaly detection. So we also have real-time monitoring and real-time exposure rates. So in here we have an example of how the detectors works. So this is an example of the neutron detector working. We place it near to a Californian 252 neutron source. So as you can see there, then we also have the gamma detector. We place an array of gamma detectors in here, and you can see how the signal is changing as we move the small source. And then we have an example of the iOS app and some of the current capabilities. So we also were able to place these in different form factors. For instance, if you have interest on hazmat teams or TSA in the airport for screening, so we have ergonomic solutions. We also have compact solutions in which they can be hidden in the belt or in a pocket, and they have quiet notifications. Or we can also place in field inspection devices, such as drones or vehicles. As a matter of fact, right now, we are currently doing field tests with the Department of Homeland Security in El Dorado, Rio Robotico. So we deploy these detectors, and they are currently serving with strong and real sources. So we have other previous partners in here. What are we looking for? We are seeking for strategic alliances for feedback and help to reach the market. And here is the team: Professor Manuel Quevedo, a founder and CEO, Dr. Lunan Fernandez, staff scientist, and myself. Thank you so much for your help and time.
Good job. Thank you. All right. Fourier. All right, sir. Yeah, you got it?
Good. Okay, so today I'm going to introduce you to Fourier, where we're innovating in thermal management solutions and disrupting it in the technical manufacturing space, technical ceramic manufacturing space. And why does this matter? Because at the end of the day, thermal management solutions depends on both innovative materials that can actually cool our electronics effectively, and also the innovative novel manufacturing to get the best materials to our devices. And so this spans industries. This is a $26 billion problem for hardware specifically. And this ranges from everything from your consumer electronics in your cell phone when you're trying to use 10 apps and you then try to take a picture and your phone shuts down just because your CPU, it can't dissipate the heat quick enough. All the way to our advanced RF devices and military applications that can suffer up to 75% downtime just in inefficiency because you can't cool it effectively enough and you don't have the right materials to apply to it. And so across the board, 55% of all electronics fail due to heat as well. And if you can cool our electronics by 10 degrees C, you gain the advantage of getting a 2x lifespan on your electronics and your systems. And also, you get a 33% reduction in your e-waste and related carbon emissions. And so this is where we come into play. And our solution is really found in lab failure, where we were looking into hypersonic applications and these different ceramic matrix composites. We came up with one that had really great mechanical strength mechanisms and also thermal conductivity. It was really great. And then we said, hey, let's put it under heat and loading at the same time. And it failed catastrophically. It deformed, but it's a full ceramic, and it deformed with large deformation. It was really cool. And it kept its mechanical strength as well. So we explored this, and then we developed a manufacturing process to control this deformation. And we then were able to encapsulate electronics like you see in the lower, here, let's point over here, into the lower right-hand corner here. There we go. And so one of the big effects of this is that we found that we had a really big cooling advantage in compared to incumbent heat sinks. Now this is based off of Raspberry Pi. This is our tech demonstrator basically, where we took an aluminum fin heat sink and then we compared it to ours with a fully encapsulated electronic system. So 15 times thinner, a 10x cooling advantage. And also because we can fully encapsulate our electronics, this adds into ideas of multifunctional packaging as well. And so how does this work? We take it basically the incumbent device that you would need cooled. We build the tooling out, and then we apply our manufacturing process. So able to then put it through our thermoforming process, produce your part, and then provide it to the OEM manufacturers to incorporate it into their solutions. And so another big thing is, like I said, the manufacturing process. So in incumbent ceramic manufacturing processes, this is where they would already have the production displayed or worked out. So you're looking at 30-day lead times, where when we have our tooling done and integrate into production, we can have a 90% decrease and deliver this in 3 days with your final part. So where Fourier wants to go from a technical demonstrator with that Raspberry Pi, going into multifunctional packaging solutions, everything from battery packaging and thermal management solutions to power electronics with conformal metallized surfaces that can go into RF devices and beyond. And so overall, where we've come from to now, so we've had some non-dilutive funding efforts, which has been really great. From my PhD work, we've been able to, Raytheon was one of our funders, or my main funder, and we've entered into a collaboration partnership since then. We have our IP from Northeastern University in exclusive rights, and we've filed the PCT into several applications, and our foundational work is in advance. And the media is up there because it's really helped build us in our network. It's been quite amazing. And so myself and my co-founder, Randy Erb, is with a great team of advisors, we're driving this company to the next level. And what are we looking for? For all of you, to help us eliminate electronic failure, advance our future technologies to where we can actually make them efficient and more useful. And what we're looking for is strategic partnerships, early adopters, joint developer partners, feedback, discussions, and also seeking investment opportunities. So if you're interested in Fourier, come and talk to me after. It'd be great to hear from you.
Thank you, sir. All right, Freefall. There you go. There's that one.
All right, thank you. My name is Aman Chandra. I'm a senior engineer at Freefall Aerospace, and I'm here to talk to you about Freefall's disruptive antenna technologies. 34% of the world today does not have access to internet. As you can see, the dark regions in this chart, this problem is not just limited to developing parts of the world. And the primary reason for that is the lack of ground networks, ground communication network ability to reach challenging terrains that are hard to provide connectivity to. Moving to a satellite-based communications network can provide the access required to bridge what's come to be known as the digital divide. Now, satellite-based communication networks do exist. Examples are Starlink and OneWeb, but they're limited to low Earth orbits, and that's really the problem. At low Earth orbits, you need constellations of thousands of satellites. At low Earth orbits, these satellites have low service lifetimes, which means that you need to feed even more satellites into this already massive network of satellites, which leads to a highly resource-intensive and costly operation that is severely limited in performance and leads to an unsustainable amount of space debris. Is there a way to move from this complex mesh to a simpler, more sustainable space-based communications network? The answer is yes. By moving to higher orbits, such as medium and geosynchronous Earth orbits, we can provide the same amount of coverage with far fewer satellites and much simpler networks. Why isn't this already being done? The reason is that good enough antenna solutions do not exist to make that happen. To really enable medium Earth orbit and geosynchronous Earth orbit-based satellite communication networks, lightweight, low power, and small satellite-compatible efficient antennas are required. And that's really where we come in. At Freefall Aerospace, we take an unconventional approach to antenna design in that our antennas are spherical in geometry. That, along with advanced feed design, gives us antennas with the highest field of view among their class in the industry. What that also does is it allows us to greatly simplify the design of these antennas, leading to low-cost, lightweight solutions. When compared with their competitors, primarily more complex systems such as parabolic reflectors and flat panel arrays, the performance of these antennas beats them hands down, especially in resource-constrained environments such as higher orbits and deeper in space. Now, we've come a long way. We've seen funding from NASA, the NRO, and the US Air Force, and our spherical membrane antenna technology is now all set for flight. We are going to be demonstrating this technology in a little over 2 months from now on board NASA's ELANA 43 flight in low Earth orbit. Using the same technology, we've developed a range of products for very diverse applications, all focused on lightweight, low-power antennas designed for extreme environments. And these have been designed specifically to enable rapidly responsive space-based networks for communication, navigation, and space domain awareness in extreme and remote locations on the Earth, in high Earth orbit to cislunar space, and on the lunar South Pole. We've seen a lot of traction with market leaders. The versatility of our products has led to development contracts from some of the world's largest telecommunication companies, and we continue to work as strategic partners with companies spearheading satellite communications and cislunar development activities. Founded by a 28-year NASA JPL veteran and a world-renowned astronomy professor, our team has grown and is today a highly skilled team with multiple decades of experience working for world-class aerospace companies. Sorry. So the coming decade is going to see about 17,000 satellites being launched. Each and every one of those antennas, each and every one of those satellites is going to need antennas. And so we believe that the time to invest in antenna technology is now. So that brings us to our ask. We look for collaboration with strategic partners to demonstrate our technology, and we seek funding to accelerate the development of existing technologies and explore other applications for them. Thanks a lot for your time. I hope you enjoyed listening to us, and I look forward to hearing from all of you and speaking to you. Thank you.
Appreciate you. Yep, I'll take that. All right. Next is level 5, Shri. There you go. There you go. This one. Yep.
Ouch. Are you looking at those? These accidents are quite common, right? They're unfortunately more common than you think. And they happen quite a lot. Usually about 40,000 to 60,000 of these accidents happen in a year, and they cost quite a lot. Each one of these accidents costs upwards of $100,000, right? And unfortunately, 1% of these accidents result in serious destruction of property and also price. Oops. Uh-oh. Click. Okay. So my name is Sri Saripalli. I'm the founder of Level 5. And our job is to make sure that no such accidents ever happen, right? We also want to automate forklifts, pallet jacks, reach trucks, so that they work efficiently and effectively 24/7. So what we do is we can take your forklift and we can automate it. We have a custom sensor box that we can affix to your forklift. And this sensor box consists of LiDAR, cameras, and radar. So with these sensors, these forklifts are able to detect obstacles and avoid them in any kind of weather and in any kind of situation. We can affix this onto your forklift in less than a day. And from the next day onwards, the operator in the warehouse is able to run the forklifts as though nothing has changed, right? So the operator goes on about his job, moving things, and as they are doing this, we learn from this, right? So we are able to figure out how the operator is moving, and we also provide safety from day one. Think of it as automatic emergency braking for your car. Your car has this, right? And so you want a forklift also to have this so that it never gets into an accident, right? But we are also analyzing the warehouse from day one. And because we are doing that, we can actually provide analytics as to what's happening in the forklift. So we have a prototype. And what we did is we took a custom off-the-shelf tracked forklift, and we put our sensor box on that forklift. The operator ran it for a day, and after a day, it became autonomous. It is able to take a 7,000-pound payload and is able to move it from point A to point B day in and day out, right? And while doing it, at the same time, provide the safety required for these forklifts. Right? So our team, we are a spin-off from Texas A&M in 2023. We have greater than 25 years of experience in autonomous vehicles. Experience at NASA, experience at Texas A&M, University of Southern California. We've been funded by DARPA and by the industry for developing autonomous vehicles, right? So if you want to go from having forklifts that usually have accidents in warehouses to something where you have accidents like this to something where your forklifts can work 24/7 in a warehouse without having any kind of accidents, please come talk to me. We are looking at pilot deployment opportunities. We have several prototypes that work on forklifts, that work on reach trucks, that work on pallet jacks. We are also looking for pre-seed funding so that we can expand this, right? Again, my name is Sri Saripalli, the founder of Level 5, and please come talk to me if you want to automate your warehouses. Thank you.
It's tricky with those videos. All right. See if I can get this. It's tricky with these videos. Am I going the right way? I don't think I'm going the right way. See, now I know why you guys are all confused. All right. Oh, I'll leave your everybody got his contact information, right? You took pictures? I see all the phones getting out. All right, Micro-Avionics.
Okay. So propulsion has shaped the course of human history. Harnessing wind allowed ships to traverse oceans, and the rocket sent humanity to the moon. Despite this progress, there's still one massive area that we haven't explored, and this is near space, a region of our atmosphere that's too high for planes to fly, but too low for satellites to orbit. For decades, scientists have realized something strange about aerosols in this region. When exposed to sunlight, they would move up against gravity. This mechanism is called photophoresis, and as a grad student at Harvard, I've spent the past 6 years studying how it works. My team and I asked the question, could we use this force to move something bigger than an aerosol? Last year, we got our answer. Yes, we can. We built a 1 centimeter wide device that levitates under just sunlight. This device takes energy from the sun and converts it into an airflow that pushes itself up. There's no fuel, power, or photovoltaics on board this thing. It's simply sunlight-driven flight. This is the only hardware that can fly between 50 and 100 kilometers, and our goal is simple, to use these as platforms for flight in near space. So let's talk about their life cycle. To start, they'd be deployed by high-altitude balloons at about 50 kilometers. From there, they'd fly up to their target altitude, about 70 kilometers, where they'd hover around indefinitely and can be geostationary over fixed points in the ground. Over a 24-hour cycle, they'll bob up and down by a few kilometers, just like naturally occurring aerosols. And at the end of their useful lives, potentially years later, they'll fall back down through the troposphere, where they'll be disintegrated into non-toxic mineral dust. So how are these platforms different from satellites and UAVs? Well, to start, their unique flight altitude means they have 1/5 the latency of LEO satellites. They can collect an entirely new stream of atmospheric data, and they are protected from the ionospheric interference that plagues existing satellite networks. Their ability to station keep lets them form geostationary communication arrays over fixed points in the ground. These can provide data directly to the warfighter, and they can help intercommunicate among different ground stations and satellite networks. Our devices can integrate with a variety of payloads. Right now, they can only loft about milligram scale payloads. However, in the next couple years, we're aiming to scale up to the gram scale with the long-term goal of lofting kilograms. Lastly, our unique form factor enables clandestine operations because they're too small to be detected by radar. They have a sustainable manufacturing process, and they can be rapidly deployed. So how can we use these platforms to solve some of the DoD's capability gaps? Well, one example would be for atmospheric sensing. A network of these sensors could be deployed passively in the mesosphere, where they'd collect climate and weather data that could then be used to optimize aviation routes and rocket launches. A passive network could also detect perturbations in the wind in the mesosphere that could alert operators to, say, an adversarial rocket launch. And we can do that without the adversary ever knowing, because again, we're clandestine. A network of our sensors could be used as a geostationary antenna array to provide ad hoc communications to the warfighter in regions that are contested or where line of sight may otherwise be lost. We can also intercommunicate among different satellite providers, because right now, a lot of the protocols that are used don't allow different satellites to talk with each other. And one fun thing about our devices is that they work in any low-pressure environment. So if there are any billionaires watching, our devices could help colonize Mars. We could use these devices as passive sensing arrays, communications over Martian bases, or even as mirrors for terraforming. And each of these would help aid Martian exploration. So we're very early, we're at TRL 3, but in the past 6 months since we've incorporated, we've reached just shy of $1 million, have formed a partnership with the AFRL, and we've attained a CRADA with Los Alamos National Laboratory. With continued R&D funding through Harvard, we're hoping to move quickly, but we're only experts on the levitation tech, not your needs. So we're looking for early adopters within the DoD to focus our fundraising and our technical roadmap so that we can more rapidly deploy these things in a way that benefits national security. My name is Ben Schaefer. My co-founder is Angela Feldhaus. Please come talk to me afterwards if you're interested in this technology or if you have a payload or use case that you'd like to see in near space. Thank you.
Great job. All right, Scarlett. There you go. Yeah, it's the right button.
Thank you. Hi, everyone. I'm Scarlett Kohler. I'm the CEO of Mithril Technologies, and I am here because, like the folks at Freefall, we're pretty concerned about limitations in satellite antenna tech. At the moment, we've got 7,500, give or take, satellites in orbit, and this is still the best that we can do in terms of hurricane monitoring because we do not have instruments that can continuously monitor the atmosphere through clouds. And I'd really like to thank Jeff for calling attention to the devastation that hurricanes aggravated by climate change can absolutely be terrible. And it's costing not only lives, but money. The insurers have been losing way way more on storms throughout the last few decades. Hurricane Ian alone cost insurers $63 billion. And as I said, at the moment, we do not have satellites that can both look through clouds and also monitor large areas continuously. That is just not physically possible. And the reason for that, actually, NASA and NOAA have been proposing instruments for decades, multiple instruments, but they require a type of mesh reflector that has a size and surface precision that currently just is not achievable. And the reason for that is because that technology has not advanced substantially in several decades until now. And that's where we come in. We use an electrostatic actuation technique that was developed in our co-founder's lab at MIT. And we are able to precisely control the surface of a reflector to break those trade-offs. This is our 1 meter prototype in the RF chamber at MIT Lincoln Lab. And at the moment, as I said, our trade-offs limit us to this kind of monitoring. But our ability to control the surface of our reflector gets us to this. We can continuously monitor the whole depth of the atmosphere across a large scan sector, and that is a game changer for monitoring hurricanes. But reshaping your reflector allows other things. We can actually do some really clever agile scanning for space domain awareness. We can also reshape your communications coverage area for any communication enabled by a mesh reflector. And we can even do signal jamming in contested environments and adaptively jam out different signals. And so because of that, we have a wide array of target users, naturally disaster response and FEMA, the good folks at NOAA, and the Department of the Navy is interested in protecting their seaborne assets. But then on the satellite communications and space domain awareness side, we're even looking at folks at Viasat and SES Space and Defense and also NRO. Not to mention, I should mention insurers. So right at the moment, as I said, we are at early stage TRL3. We have a lab prototype where we've been able to demonstrate our ability to precisely control our mesh surface. But we're now working to scale up to 5 meter and longer term, even 50 meter reflectors. And in the end, we do want to be able to operate our own satellites, supply a unique and essential type of weather data for a variety of customers. So we have a brilliant team. My co-founder, Zach Cordero, is a professor in MIT Aeroastro, and he's been developing this tech in his lab for several years, building on some of his previous research at Rice and Oak Ridge. I, on the other hand, have done 5 years of systems integration and test at SpaceX and JPL before coming back to MIT for the Leaders for Global Operations program, and I am your rubber meets the road, how do we actually build the thing person. So we're already working on generating traction. We've got some great partners at Lincoln Lab, at AFRL, and we've got some supporters at NRO and JPL. And we are now opening a pre-seed round. So we'd really love to talk to you if you're interested. We've got some space for a couple more checks. And any connection to Space Systems Command would be helpful because we are trying to engage with customers specifically in the Space Domain Awareness Program office. So that's my email up there. Please reach out if you have any questions. And don't worry, we are also talking to Freefall Aerospace because we think there's some synergies.
Oh, got it. All right. Modifly. Here you go, sir. There's that.
Good. I think it's still morning. Good morning, everyone. My name is Jeremy Cofield, and I am a founder at Modifly, and we are a spinoff from the University of Texas at San Antonio. So if you've read the news recently, you'll see the usage of drones by both our allies, as well as our enemies. And so with all of this innovation and work inside of the drone field, there is still one question that remains being asked. Where's Skynet, right? With all this work, where is Skynet? Where is this network of interconnected drones? And there's a big, big problem that's actually plaguing drone development. And to highlight this problem, I'd like to introduce you all to my friend Dave here. So Dave is a researcher, or he's a systems integrator, and he's trying to put his algorithm or his module or something on a drone. So he goes to our competitors and he decides, hey, I'm going to spend $3,000 on this drone, and what they basically give him is a circuit board, some motors, and a note that says good luck, right? That's not very helpful for Dave. So he has to go install the software, he has to update everything, he has to chase down problem after problem after problem. He has to run command after command after command, and it only seems that he's just getting into error after error after error. So for Dave, it's like putting a square block into a circle hole. Things just don't fit. They don't match with each other. And so Dave is confused, and he hates this process because he wants to implement his algorithm. And he doesn't want to worry about networking or safety or compression or security or control theory or firmware, and the list goes on and on and on. All Dave wants to do is just add on his algorithm. He doesn't want to do anything else. And that's where Modifly comes in. We combine the hardware and the software to create a continuous integrated system. So let's talk about the hardware. So that is our Mark II Lite prototype right there, which uses a AI coprocessor as well as a very cheap processor as well, but it's very, very performant. It has a quad-core 8 gigs of RAM. So how does it talk to the outside world? Well, there's 4 ways of connection. A cellular LTE interface, a 2.4 gigahertz radio, Wi-Fi, Bluetooth, and plenty of other more networking ideas that we still have. And then expansion. Because we wanted to be a drone that can just do multiple things, we built our own system for allowing modules to be attached to the drone through a simple plug-and-play system. No more configuration, no more reading through instruction manuals. You get the module, and you just slot it in. And it works, and all the communication stuff pulls up, and it's able to identify what type of module is connected. And this allows for dynamic mission demands and capabilities where you don't need to buy one drone that only accomplishes one purpose. Now you can buy one drone, and you can slide in whatever module that you want for whatever mission purpose that you might actually have. So let's talk about the software then. We're able to add an object detection neural network in only 6 lines of code. That's because we wanted a simple interface that people can use to expand the capability of our drones as much as possible. Because there is a famous man who once said, when you give developers amazing tools, they do amazing things. So deploying this software, how do we deploy it? So with Modifly, in our system of networking, you run one command, and it takes all of the code inside of your project, and it pushes it through your swarm of drones at that time of command. And they take in the new code. If they're already running the code, they stop it, and then they restart it. So to demonstrate our technology and our capability of doing all of this software, we decided let's put it to the test. Let's try and actually build something useful with it. So we made a cockpit application. So that cockpit application that you're seeing right over there, that was built by us using our own scripting engine. And it was all of the drawing, all of the communications, all of the telemetry, and even the controls, and taking in controls from a joystick. It was all done in less than 500 lines of code. So what does less than 500 lines of code mean? That means that one afternoon and a few cups of coffee, you're able to make a mission-ready system. So why? Now, I had something prepared for this, but there was a Wall Street Journal article that came out yesterday morning, and it was talking about the Ukrainians. And the Ukrainians, their drone capabilities are not being met satisfactorily by US companies. And that's because the US companies are not innovating fast enough for them. And frankly, it's really, really tough because our allies in Ukraine are now using Chinese DJI drones instead of American-made manufacturers, which is terrible. And so we need a system which allows you to quickly deploy software to meet their needs and their mission demands. In summary, you need easy development, which saves you money. You need easy deployment, which means you have 0 downtime. And you need easy management, which gives you a scalable system. So I'd like to introduce our team. So we are a spinoff from the University of Texas at San Antonio, and we are supported by the Naval Research Laboratories as well as the Army Research Laboratories. So what do we need now? First, we need feedback. We need to know what we're doing good, and we need to know what we're doing bad. And next, we need partners. We're a bunch of engineers And we don't really know how these things are actually going to get used in the field. We don't know how these drones are going to be applied, and we need to be enlightened on those applications. So thank you very much for listening to me ramble on. Like I said, we need feedback and we need partners. In short, come fly with me. Thank you.
Good job, buddy. All right. Next up, Pi Radio.
Thank you, Josh. Thank you. Hello, everybody. My name is Aditya, and I am one of the co-founders and I'm the CEO of Pi Radio, joined here by our CTO, Mike, and our company makes software-defined radios. It is no secret that electromagnetic spectrum is the invisible lifeblood of the modern battlefield. It is used for communications and for sensing. And over the past few years, there have been tremendous developments in foundational wireless hardware. And these developments now allow us to use more and more of this electromagnetic spectrum. Furthermore, the DoD is investing quite heavily in leveraging 5G and beyond for next-generation tactical communication systems. And this combination of more spectrum with next-G technologies can give warfighters significantly faster wireless connectivity, while also being more resilient to attacks like jamming, eavesdropping, and spoofing. Software-defined radios, or SDRs, are essentially reprogrammable radios. They are used to build communications and sensing systems. And they are used all the way from developing simple in-lab prototypes to being deployed in real battlefields. But in order to really use software-defined radios, what is needed is a capable workforce. And the unfortunate reality is that there is a giant gap between what warfighters need and what a typical research laboratory is capable of producing. And in order to maintain electromagnetic dominance, we must bridge this gap. And in this regard, the US is falling behind competitors like China, and this has been widely acknowledged by public statements made by leaders in both the civilian and the military domains. And the bitter truth is that American universities are simply not producing enough engineers who know how to build real-world wireless systems. But why? A big reason is that advanced software-defined radios are simply not prevalent enough within research labs. Without advanced software-defined radios, engineers cannot build or even learn how to build the wireless communication and sensing systems for tomorrow. And to address this problem, it is Pi Radio's mission to make sure that every wireless engineer has access to affordable software-defined radios that they can use in their labs to build real systems. As an analogy, we kind of take it for granted that every computer science student should have access to computers, right? That is obvious. In much the same way, widespread proliferation of software-defined radios is critical in ensuring that the US produces a workforce that is capable of maintaining electromagnetic dominance. So when we come to software-defined radios, let's talk about our competitors a little bit. So most other software-defined radio companies don't even have products that operate in these emergent and new frequency bands. And of those that do, their systems are either too expensive, too primitive, or both. At Pi Radio, we build affordable software-defined radios in a wide variety of emergent bands, ranging all the way from 6 gigahertz to 140 gigahertz. And you can see some of our radios on the slides, as well as Mike is holding up our latest software-defined radio. And in addition to actually building the SDR hardware, we also assist with software development, system integration, antenna design, testing, and so on. All of our products are loudly and proudly designed and manufactured right here in the US. And Pi Radio has been funded thanks to the generosity of the American taxpayers through non-dilutive vehicles like the SBIR and STTR programs run by the Army, NSF, and DARPA. Some of our customers are also shown over here. And as you can see, most of our customers are from the civilian/educational space. And as we speak, we are working towards entering the DoD ecosystem. Pi Radio has an experienced founding team. As just one example, our co-founder, Sandeep Rangan, was also the co-founder of this company called Flareon Technologies that developed the technologies that then became 4G.
Flareon was bought over by Qualcomm, and the rest is history. Every single person in this room has used 4G. And in addition, Pi Radio has also assembled an advisory board of people who are pretty well known in the civilian and educational spaces. But like I mentioned, we are working towards entering the DoD ecosystem, so any help towards this would be greatly appreciated, and this brings us neatly to our ask. We would like to shamelessly ask whether you could please help open doors for us. We would grab at any opportunity to speak with people who work at either DoD labs or DoD-funded research labs, people who are looking to build next-generation communications and sensing systems, perhaps with anti-jamming, eavesdropping, or spoofing capabilities. Next, we would also grab any opportunity to talk with people who work at the traditional defense primes, people who are looking to partner with a small but nimble startup and translate these technologies faster from lab to battlefield. With that, let me end here by saying that Pi Radio is a company that builds software-defined radios. We are made in America, for America, and anybody else in the export control list. And thank you for your time.
Good job, buddy. That was great. All right. Refined imaging. Les. Here you go, sir. There's that, and there's that.
Thank you. Happy to be here. The issue is secure supply chain solutions. Our team has been working together for 5 years. We've pulled together a variety of talents, and we believe the solution is a cyber-physical trust anchor. The team consists of Ian Taylor, the CEO of SymbiChain, and brings together blockchain expertise. We have Professor Michelle Mossberg, a professor of cyber science at the U.S. Naval Academy, and myself, professor of chemistry at Louisiana State University, and I bring in advanced X-ray and neutron imaging and some experience in additive manufacturing. So refined imaging is a spin-off from Louisiana State University. So this issue of problems in the supply chain is widespread. It affects many of us. It affects Amazon, Caterpillar, Black & Decker, Lockheed, Delta Airlines. It's just a widespread problem throughout our manufacturing sector. And it also can be very personal. In her time as a Navy helicopter pilot, it wasn't a counterfeit issue, but it was a part authentication issue. She did a pre-flight and found that the wrong rotor nut was installed on her helicopter. And then the adversary's favorite attack vector into our secure supply chain is something called blacktopping. And this is an unfortunate example. June 30th, 2020, a pilot tried to eject from his airplane, and the ejection failed, and he died. The Air Force Research Laboratory inspected the sequencer and found that there were semiconductor chips that showed signs of sandpaper and fresh black paint. This is called blacktopping. Likely those chips were extracted from a junkyard where they had once upon a time been in an automobile and had reached their end of life. And this is an issue of chain of custody of authentic parts that has failed. So this chain of custody versus provenance. Provenance is what we really need to install into our supply chains. And in our internal discussions about the difference between chain of custody and provenance, we like to think of terms of a motorcycle bar, and if you drop a $100 bill and someone picks it up, who owns that bill? How do you establish chain of custody versus provenance? So this requires expertise across a broad variety of areas. It requires the blockchain, the immutable database. It requires an assessment of the attack vectors and the hashes to store information, and it requires the ability to inspect parts at some various level with conventional X-ray imaging or interferometry X-ray imaging, and the figure shows a 4-kilometer long interferometer at LSU that was recently used to discover gravity waves, and some of the technology, the data analysis technology, has ended up in our hands as part of one of our patents. So how do we put all this toolbox, if you will, together to solve something? Introduced by SymbiChain in 2022, was just a very simple cyber physical trust anchor, but yet it's very effective. This simple trust anchor enabled the farmer income to increase 7-fold. They got rid of the artificial coffee beans entering this secure supply chain of supposedly sustainable coffee beans. Well, with NIST SBIR funding, we've extended this concept into polymer additive manufacturing and even things like identification of counterfeit tires through acoustical signatures. And with the interferometry techniques, we've gone up to additive manufacturing in metals, high-tech metals, and established through ASTM dumbbell testing and X-ray interferometry and fatigue testing the validation of these digital codes into AM parts. So imagine that we have a toolbox that needs to be tested. What we're looking for is a pilot study with parts that need to have security established through provenance and provenance linked to blockchain technology. So let's collaborate, let's talk about your workflow, and let's find a way to efficiently link these toolboxes to your part. Thank you.
All right. Next is SoloPulse. Allison. We're almost there, guys. I promise. And lunch is here, so hope you are hungry. Sorry, stream.
Awesome, thanks. Okay, I will make this entertaining because I am competing with lunch. But it's great to see you all here today. I am Allison McKinney. I'm the CEO and co-founder of SoloPulse, and at SoloPulse, we're changing how the world sees. So this is a problem that many of you in this room may be aware of, but advanced threats are overwhelming our radar technology. So the problem of why this is happening is because the mathematics behind how we use radar actually hasn't been revisited since World War II. So I'm going to dive into this problem a little bit more, but I also want to bring home that this is something that we're facing. We've just lost U.S. soldiers within the last 2 weeks because of drone attacks. So this is a very real problem. I actually know this problem from more of a personal experience. I worked at Georgia Tech's Research Institute as an air and missile defense algorithm developer, and this was something that we faced every day when we were trying to do algorithm development to look at these specific threats. So what does this problem actually look like? So using a military radar, if you're looking for a quadcopter, below is the image that a radar sees. So does that look like a quadcopter to you? Not really. It looks like a blobby image, and so what we're able to do is its signatures, how we move around, that's how we start classifying it. But because of the way that quadcopters moves, it makes it really difficult. So the issue comes down to two things, latency and resolution. So what does SoloPulse do? We're actually able to take existing radar technology and we apply advanced physics models that's based in quantum physics, and that image that you saw on the previous slide, actually the exact same data set was used to create that image at left. So we're able to create a 3D image from an existing legacy radar technology with that data set. And the metrics that you see on the bottom of the slide was done from a DARPA-funded effort. So we have that 10x resolution improvement. There's actually a 70% processing power efficiency gain, and it's 1,000 times faster. But we don't want to just stop at unlocking it through physics. We want to apply the next capability of applying machine learning and AI to be able to do advanced classification, because that's where the rubber hits the road. So that's where we're focusing our develop on right now. So there's two ways to deploy our technology. One is actually processing as a service. So in the radar community, there's a lot of things that's used for the Intel community where data is based on a server. We're able to do that now. And where we have done, we're at a tier level 6 for our second product, which is doing this at the edge. So we can deploy this on FPGAs, GPUs, or different things like that. So I won't go into all of these key scenarios, but I do want you to take a look up here and see if any of them identify, if you know or if you know someone who has a keen interest in these applications. We are currently looking to move from tier 6 to tier 9, so we're looking for people who are integrators and end users who can help us jump to the next level of our radar capability. So founding team, myself, Victoria Rishi, and then Dr. Michael McKinney. We also have 2 formal advisors, Chris Barnes, who has 30 years of experience in the DoD and actually sits on the global committee for SAR, and then Nishant Batra, who's the Chief Strategy and Technical Officer at Nokia. It's wonderful to have these 2 advisors because this is not just a problem that we're facing sort of on the military side of things. This is also a national threat when it comes to our commercial side of things. So this is very much so a dual-use problem. We have some amazing groups that we're affiliated with, and we are looking forward to growing those affiliations. So would love to get in contact with anyone who wants to help change how the world sees by unlocking radar's true potential, and thank you all for your time.
All right. And last but not least, Spectrum Defense Systems. Here you go, sir. There's that. And there's that.
Hello, my name is Joseph Peterson. I am the CEO and co-founder of Spectrum Defense Systems, and we are a startup focused on providing radio frequency emitter systems to the US military. Now, I want to take a bit of a step back as to why we're developing this. During World War II, the Allies, in advance of the invasion of Europe, set up inflatable vehicles, wooden aircraft, and fake airfields to deceive the Germans on where the invasion would take place. Fast forward to today, and the battlefield is transformed. Advances in military technology have not only enhanced our capabilities, but introduced new vulnerabilities as well, particularly in electronic warfare through the tracking and identification of warfighters via radio missions across the spectrum. And with the recent transition to more larger scale conflicts, such as the Russia-Ukraine war, these vulnerabilities are more prevalent than ever before. Now, I want you to imagine that every signal sent out is like a beacon in the night, and our adversaries are actively seeking out these beacons using various types of instruments. So, if you have a radar system, for example, emitting signals out into the spectrum to look for oncoming aircraft, adversarial forces can locate these systems, which can compromise mission objectives and risk the loss of life on our side. We need a way to mitigate these risks and bridge this gap in our EW capabilities. And this is where we come in. Our flagship product, the Dynamic Radio Emulator System, or DRES, is a modularized emitter system designed to replicate various military RF signatures, and it is currently comprised of 2 main components, the command interface and the deployable emitter nodes. This provides the ability to obfuscate warfighter positions and disseminate misinformation to adversarial intelligence. The command interface utilizes TAC, the Team Awareness Kit. The command interface utilizes TAC, the Team Awareness Kit, for managing the emitter nodes, and this works for maintaining geospatial awareness during deployment and also being able to manage the emitter nodes. It currently includes both WinTAC and ATAC integration. The emitter nodes are managed wirelessly via a mesh network and can be configured before and after deployment from the central interface, emulating the desired radio signatures across the spectrum. These nodes can be placed individually or in groups to replicate different systems and units. So if you wanted to, for example, replicate a group of tanks communicating with each other, you can simply deploy the emitter nodes, configure it on the app, send out the instructions, and the emitters will replicate it. Now, I've told you what our product can do, but what kind of progress have we made with it? So, since we started working on this back in June of 2023 for the 3rd Infantry Division during an internship that my co-founder and I completed, we've had the opportunity for them to field test it on 2 separate occasions. They've been our primary partner, and we've been working closely with them since then. We are also currently participating in Vanguard 2024, and this is an EW capabilities testing event hosted by the United States Intelligence Center of Excellence, and they will be using our emitter system for threat targetry and training all their various sensors. Additionally, we've also established strategic relations within the United States Indo-Pacific Command and Program Executive Office IEWNS, and they are helping us to land some upcoming contracts as well as getting us into upcoming testing events. Furthermore, on the financial side, we've successfully raised $25,000 in non-dilutive funding, $5,000 of which came from a Purdue pitch competition, and the other $20,000 of which came from the Emerge Accelerator as part of Ensign. So what's next? Well, our primary concern or focus moving forward is on scaling up the development of DRES, especially in collaboration with the 3rd Infantry Division, who has already expressed interest in becoming our first customer, with a potential sale for a large amount of our emitters this coming July. Additionally, our involvement in Vanguard, coupled with an increasing amount of interest from various military divisions, has unveiled substantial opportunities beyond our original scope of the product as just a decoy system. These different divisions are interested in utilizing DRES for training applications, such as simulating complex and contested electromagnetic environments, as well as testing out their various systems and training their soldiers. And this presents us with an opportunity to expand our customer base. Now, as mentioned earlier, this was founded by me and my co-founder. I am the CEO, and I am currently working towards my bachelor's in computer engineering at Purdue University, and we'll be graduating this spring. My co-founder, Alina Miles, and the CFO, is currently a junior at Ohio Northern University and working towards her bachelor's in mechanical engineering. In the span of less than a year, we've managed to take something from no more than an idea to a complex device being used by warfighters across the Army. We are Spectrum Defense Systems, and we are providing versatile emitter systems to the US military. If you or anyone you know are interested in emitters and how they can be integrated into your mission sets, please reach out to us. Thank you.
Good job, man. All right, one final applause for the teams. It's really hard to get up here for these teams, so. It's amazing, and I wasn't lying when I said these teams are changing the world. They really are, and I'm proud to have worked with them for the past 12 weeks and see all the progress they've made. So thank you again for being here. Stick around. We are officially here till 2 o'clock, so there's plenty of food. Hang out, get to know the founders. They would love to get to know you, and thank you very much for being here. Thank you.